This is a tutorial for question 13 on the Unit 3 chapter test. I'm going to move my calculator out of the way here. And this question is about a child standing in a boat and then jumping to the right. So if we're going to show this on the Data Studio lab, this is a lot like what it would look like. So let's go ahead and take a look at what's going on here. We have a child who is standing in a boat. So the way we can look at this is the child is standing in the boat, and that is the child is going to be the blue one. It's the lighter of the two, so that is going to be the M. And the boat is going to be the red one. It's the heavier of the two, so it is going to be the red M. So this is before they jump out. Now it's not a collision, it's a jump, but it's the same idea. So before they jump out, it's like this. And then the child will jump to the right, and the boat will move to the left. And now they're separate. So this is the boat moving to the left, or negative, and this is the child jumping to the right, or positive, and this is them together at 0, not moving anywhere. So it says, what is the momentum of the 36 kilogram child before the collision? So the child is 36 kilograms. So here and here, the mass of the child is 36 kilograms. And so I'm going to put 36 there and 36 there. That's the child. The mass of the boat is 56 kilograms, and that's the red one, remember. So this is 56 kilograms, and this is also 56 kilograms. So filling in the rest of the values, this V is 0, and the reason, of course, it's 0 is because it is a stationary boat. It is not moving. So this is 0, and whatever this is going to be equal to 0 on this side. Alright, this is going to continue here. It says the child jumps to the right at 2 meters per second. So the child is going to jump to the right at 2 meters per second, so that's a 2. And if you total those up, that is going to be a 72 total momentum. And then here, we can't total this up because going down the bottom, this is the after. The child jumps off the boat to the right, 2 meters per second. What's the boat's velocity? And so going back to red for the boat, what is the boat's velocity? The boat's velocity here would be 56 V. And so that's the question. What is the V of the boat? So we're going to solve for that, 56 V. So here I am. I got 0 on this side. I got 56 V plus 72. So I add negative 72 to each side to get the 72 off of that side onto this side. And I get 56 V. And if I go back to my calculator here, now I have 72, and that's a negative divided by 56 equals, and I'm going to get about negative 1.2857 and negative 1.2857. And I don't really have to carry it out that far. Oh, by the way, that's meters per second. I don't really have to carry out that far, but I'm going to anyway. Is equal to my V. And I'm going to do that because I want to plug it back in. And when I plug this back in to actually not that part of the equation, to plug it back in right there, you're going to see that this plus this does indeed equal 0. So you'll see that this side is a total of 0, and this side is also a total of 0. So answering the questions one at a time then, what is the momentum of the child before the collision? It's 0. It's not moving. And then, of course, all of the momentum units are kilogram meters per second. What is the momentum of the boat before the collision? Of course, it's also 0, being that it's also not moving. What is the total momentum before the collision? So the total momentum, of course, is the child and the boat. They're both 0. And what is the total momentum after the collision? That's what I just said, that 0 equals 0. This question we already answered, negative 1.2857 meters per second. So if we put this back in, do we really have 0 is equal to 56 times a negative 1.2857 plus 72 equals 0. So here we go. This times 56 equals a negative 72, of course, plus 72 equals 0.